This is a quick animated essay on how we on Earth view and measure light coming from the stars and how we interpret these findings by creating theories, and how people tend to cling for centuries to old theories that later turned out to be wrong. In past ages, there were a few geniuses that looked at the stars and interpreted the observed findings and came up with logical, plausible theories to explain what they had observed. So far, as we will see, most of them have been wrong. Now, these philosophers were not crackpots. They were serious, respected, and renowned scientists in their day, and they used their intellect wisely to arrive at their theories. But then, here's the problem. Generations upon generations of following would-be scientists took these plausible theories and somehow transformed them into absolute natural laws and then taught them to other would-be scientists and so on. As technology progressed, new and more refined instruments and methods explored the universe and provided new and more detailed observations. New data became available, revealing more about our universe. However, these ancient theories were not challenged. So, we tend to cling to the old theories despite the fact that better observations no longer fit, because for generations, these theories had been accepted and solidified as these absolute natural laws. Until at last somebody comes along and says, hey, that theory no longer fits. The observations don't match it. They don't match. And then, as in the past, the new genius comes up with a new theory to match the new, presumably better observations. It's interesting to look at some of these theories about our universe as they developed over the centuries. We'll start with the ancient Greeks. A large number of philosophers looked at the sky and came up with similar logical conclusion. The observed facts were that the sun and moon and planets and stars circle around the earth. Archimedes was one of them, and he logically concluded in theory that the earth is the center of the universe and everything revolves around us. It made sense, and it fit the observations of the time. But it was wrong. The flaw in that theory, obvious to them then as well as to us now, is that there were few stars that did not go around as the rest. They wandered around the sky. Nevertheless, they were conveniently called exceptions to the rule. So they were named planetes or wanderers in Greek. So such convenience factors explained any observed flaws in their theories that persist to today. More on that later. So for the next 2,000 years, untold generations of would-be astronomers took the geocentric theory as an absolute fact and taught more generations of students something that we now know is wrong. Nevertheless, these generations of scientists came and went, believing this to be an absolute natural law. What's more incredible is that these so-called scientists accepted geocentric theories for those thousands of years, despite the fact that the contrary evidence that they were wrong, that is, the planets' paths, were staring them in the face every night and could be seen with a naked eye and simple measurements. Moving on, with better instruments, the observations of scholars started not matching well with the Archimedean absolute natural law that they had been taught. There was the usual effort to find plausible explanations to somehow shoehorn what they took as aberrations to make them fit. But at some point, someone with the fortitude published the error. In 1543, Nicky Kepler noticed that the observed facts led to a more plausible logical theory. Kepler placed the sun in the center of the universe, and the earth and planets and the stars circle around the sun. Having better instruments than the ancients, he was able to trace and calculate the paths of the planets. But although he had more accurate measurements, He actually did not need his superior instruments to come up with his theory. The ancient measurements would have sufficed. So, 2,000 years of faithful teaching were destroyed. The heliocentric sense of the universe, then, was corroborated in 1632 by Galileo Galilei, who, using a high-tech instrument of the time, a telescope, spotted moons circling the planet Jupiter, and who further collected additional observations to show that Jupiter and the other planets were circling the Sun, confirming Kepler's theory. Thus, the theory of heliocentricity of the universe was confirmed, and of course what followed was that it became more than a theory. It became, again, an absolute natural law, and many generations of would-be scientists believed and taught it as fact. But although between them they destroyed the previous theory, the new theory was also wrong. Moving on some more time, there came along better observations using better and better telescopes, etc., and people started to have doubts about the Sun being the center of the universe and everything spinning around the Sun. The first chink in that heliocentric armor came in 1717 by John Wilson, who frankly speculated if indeed we were not simply a part of the Milky Way, or galaxy as named by the ancient Greeks. The galaxy was always there to be seen since men looked up at the night sky, but it was the first time that the heliocentric theory was challenged. Subsequently, more and more and better observations led to the theory of the universe, at the time consisting, of course, of the Sun, Earth, planets, and stars, were part of the Milky Way, and that we were located in its outskirts somewhere. This lasted into the 20th century, and once again generations of would-be scientists were taught this and used it as fact. But it was also wrong. By the 20th century, astronomy had become a serious, well-funded field of science with improved instruments, and thus we had a better set of observations, and of course accompanying logical theories to match them. In 1922, that is roughly 100 years ago, Edwin Hubble announced that the universe was not the Milky Way, that the relatively nearby Andromeda Nebula was not part of it, but was outside, much further away, that there was a lot of stuff out there beyond it. Thus, the Milky Way-centered universe theory was shattered. Again, it was wrong. Enough of this history. Let's get on with our philosophical experiment. It starts with Hubble and company looking at the so-called spectrum of the light coming from stars and comparing it with that from the Sun, our nearest star. They saw that some spectral lines coming from stars, spectral lines are these thin black lines in the colorful spectrum. Anyway, he saw that these spectral lines did not line up and match with those of our Sun. Just about all seem to have shifted towards the red end of the spectrum, each having a different amount of shift. Okay, that's scientific observation. Now here comes the theory. If an object is moving away from us, the photons, that's the particles or waves of light, would tend to stretch away a bit so that when they reach the sensor is us on Earth, when they reach the sensor, they have shifted their frequency slightly towards the slower or red part of the spectrum. Thus, the theory holds, the more the star's red shift is pronounced, the faster that star is moving away from us. Once again, a plausible, logical theory based on scientific observations of our time. Unfortunately, these theories do not stop there. Somehow, they also state that the more the red shift, the further away a star is. Now, how they got this second part, I surely haven't fathomed. So, here's the test example in simple animation. We will look at 4 assumptions of light sources, that's the stars in galaxies, the light sources, sending photons, that is light, into our direction. We take snapshots of these light sources and study their spectrums. Let's assume for convenience that our sensors need 5 photons in order to capture the single snapshot. we can first look at the photons coming from our sun. They take about 8 minutes to arrive to Earth, and we can check their spectrum and use it as our scientific baseline. Next, we look at the photons coming from a star that is hypothetically a very long distance away, but is not moving away from us. Our distance is remaining the same. Now, the photons from that star may take years or even millions of years to arrive, but note the photons have not been stretched by speed. Thus, upon arrival, their redshift should not have shifted at all. Next, we look at the photons coming from another star that is also hypothetically a very long distance away, but is moving rapidly away from us at some given speed. The photons from that star will also take a long time to arrive, but note, the photons would have been stretched by its speed. Thus, upon arrival, their redshift should exist and could be measured. Last, we look at the photons coming from yet another star that is hypothetically much closer than the previous one, but is moving away from us at the same speed as the previous one. Its arriving photons would also have been stretched by its speed, and what's more, they should have been stretched the same amount, same speed, same stretching, and that the redshift should exist and could be measured and should match the previous stars. However, remember we had placed the previous star hypothetically much further away from the last star, yet their redshift should be identical since their speeds are identical. Yet somehow modern theorists extract also a measure of distance from the redshift values, which becomes an almost circular argument. They treat redshift combination of distance and speed measure as a fact, not merely as a contemporary theory. We are bombarded today with very elaborate graphics and animations of superb technical and artistic quality, so the previous example may seem a little crude. But do not let the quality of their fancy animations mislead us into accepting them as representing reality. They are only artist depictions of someone's current pet theory, such as the incredibly beautiful but wrong metal models made in past ages. Let's get, finally, to today's world. The astronomers of today have multiplied in great numbers, technology has provided them with superior instruments, and they have developed an almost feeding frenzy in their so-called discoveries, which are great because they expand man's knowledge. We hear of discoveries of binary stars, red giants, white, red, and brown dwarfs, novas, supernovas, globular clusters, Cepheid pulsars, neutron stars, and the wildest, so far, named quasars. This is perfectly okay. They are looking for the first time in man's history at a few grains of sand on the beach, and each one is different, so they're trying to list and categorize them. But when they start interpreting what they see, that's where the problem starts. They have also become enamored with the so-called Big Bang theory, which is just that, a theory, and is even now being questioned by inquiring minds that are trying to interpret new, conflicting data. More recently, we hear of the black holes, from which allegedly nothing can escape, not even light, and yet in the same breath they announce discoveries of intense radiation beaming outward from these unseen black holes. Now, how can that be? Unfortunately, most astronomers are professors, and professors are saddled with a policy of publish or perish in their profession. Since their instruments are looking at a tinier and tinier part of the universe, their theories are likely to be compared, from perhaps too harsh a perspective, to trying to blindly envision an elephant while only touching a tiny tip of hair on his eyelash. What's more, if a young astrophysicist has an inkling that a presently acceptable ensconced theory is wrong, he'd have to be very careful in declaring it, at least until he could land a job with a tenure at a university. This is no joke. The even worse trend is that with the internalization of the astronomical data, and there's a great deal of fascinating data coming out from a slew of truly technological wonders, that the recorded information is made publicly available 1 year after its collection. So it's putting pressure on the prime investigators to publish their theory, anything, before the year is out. They must publish before the year is out, so they won't get scooped by a colleague using the data they themselves had worked so hard to obtain. Astrophysicists have now become far too enamored with mathematics. For example, mathematicians have always unabashedly accepted that an equation can have two equally possible results, positive and negative, and that is somehow matter and antimatter and the whole parallel universe. It's a conjured language, very useful in day-to-day affair, but flawed at that level. Astrophysicists of today have also become enamored with Einstein's equations, of which is just another conjured mathematical language with its own admitted defects. Even Einstein had to add a lambda to his special relativity equation, which is another fudge factor, to make the equation have a better match with observed data. Again, with a modern edict to professors, publish or perish, it's no wonder the mathematicians are cranking out more and more complex equations. They appear to be sensible mathematical equations, but one looks at them carefully, one discovers that they're full of so-called constants of many varieties and names. But they are not constants. They simply think they are. And actually people are trying hard to determine them and failing. But these so-called constants are nothing more than mathematical fudge factors that try to legitimize their equations to somehow fit with observed phenomena. They are poorly defined, unmeasurable, and serve the same purpose: allow theories to be shoehorned into their mathematical formulas to somehow legitimize them, as though they represent the observed data. Even the once hallowed Hubble constant has been downgraded to Hubble parameter. It's no different than what the ancients were doing to explain away that the planets, for example, were a convenient exception to their basic flawed theories. At any rate, they have recently developed the basically mathematical concept of gravitational waves, and using equations, they believe somehow they can tell us what's out there, to say nothing of the black matter, or worse, black energy, for which they admit they have no clue what it is, what exactly it does, yet they think they dominate the grand scheme of the power of the universe. Yet they will not abandon the previously established latest theories they have been taught. My opinion is that today we simply have a repeat of history. They are trying to shoehorn again new, unexpected observations into old theories which had been taken as absolute natural laws because that's what they had been taught. And we are likely in the cusp, perhaps in this generation, that new emerging true scientists reviewing new data or even reconsidering the old are about to discard most of these theories, including Einstein's special relativity, by the way, but keep the meaningful parts and provide a new fresh theory that will better tie things together. Until next time, of course. Well, I'm done. Here comes my transport. So I wish you all well and keep from stepping into black holes.